Okay, now that you've tried one problem on your own, you can see the solution that I have here posted on the video. So check it out. Does your parabola look like mine, where you have a vertex at 5, -16, and then you have the axis of symmetry at 5, so here's your axis of symmetry, and then your X-intercepts are at 9, 0, and 1, 0. I hope it does. If not, you better make some corrections. Now I'm going to get you started on the third one because it's a little different, a little more challenging, and just to make sure you got it, because it's not like what we've seen before. So let me kind of enlarge it a little bit. Move that out of the way. So we have y equals -x squared plus 4x plus 5. So what's different about this is that the quadratic term is negative, okay, -x squared. So let's find the y-intercept where we let y equal 0. So it's the opposite of 0 squared plus 4 times 0 plus 5. And so that ends up being, well, the opposite of 0 is just 0. And then we have plus 0. Oh, my 0 pluses aren't working out, plus 5. So we end up with y equals 5. Now remember, this is a point, so we write it as an ordered pair. 0, 5. Man. Okay. Now factored form. This is what's different. Because we've always factored quadratics where the x squared is positive. But this time, it's negative. So when we factor it, we know that an x times a negative x will make a -x squared. Now we have to use 5 and 1 to come up with 4. Okay, so let's see, if I put, it has to be positive 5, right, times positive 1. Now let's double check that. Does that work? So see, that's 5x minus 1x is 4x. Good, that works out great. Now we set that equal to 0 here to find the x-intercepts. So I have x plus 1 times the quantity, x negative x, woo, plus 5. Now set each of those equal to 0, and you can find your x-intercepts. X plus 1 equals 0, so x equals -1, and then negative x plus 5 equals 0. Now be careful with the negative, so you get -x equals -5. So that means positive x equals positive 5. So we have our two x-intercepts at -1, 0, and at 5, 0. Okay, now the axis of symmetry and the vertex are going to be pretty similar to what you've done before. So we have to find the average of the two x-intercepts. So it's going to be -1 plus 5 divided by 2, which is 4 divided by 2, which is 2. So the axis of symmetry is a line, so it'll be at x equals 2. Now the vertex, now be careful when you plug in this 2, because it's the opposite of 2 squared plus 4 times 2 plus 5. Would you have caught that mistake there? That this would be -4, not +4? Okay. -4 plus 8 is 4, plus 5 is 9. So our vertex is at 2, 9. Now graph all of these things, and what you should notice is something a little bit different about our parabola. Pretty nifty, huh? Okay, so I'm just kind of going in there. So this parabola, the y-intercept is at 0, 5, 1, 2, 3, 4, 5. The intercepts are at -1, 0, and 5, 0, 1, 2, 3, 4, 5. Then the vertex is at 2, 9. So 6, 7, 8, 9. Well, what looks different about that? So the vertex is there, and we know the axis of symmetry is at x equals 2. So instead of the orientation being up, this parabola has an orientation of down. So this parabola opens downward. And see how the negative quadratic term affects that? Fantastic. Now you finish the next 3 graphing using the same procedure.